The physical universe is not constructed from material particles. It is built directly from structured mathematical language and operators. To see how this works, we trace a pipeline where pure arithmetic data becomes an emergent physical metric. We start with an arithmetic input, pass it through a Langlands lift, constrain it via a Dirac operator, and push it forward into physical reality. Our baseline is a smooth arithmetic curve. To build physical structures, we need an engine room. Here, the engine is spectral projection. This equation is a mathematical sieve. It takes raw quantum spectral data from a Dirac operator and stabilizes it. Once stabilized, the Adelic valuation operator factors that density out across all local places of the adele ring. By stripping away the high-frequency quantum noise, we isolate a finite-dimensional stable subspace. You have to stabilize this mathematical data before any physical geometry can exist. Now, we convert those continuous quantum states into discrete arithmetic structures. We use the semiclassical intertwining operator to build a direct mathematical bridge between the spectral data and automorphic forms. The J inside this trace kernel serves three precise functions. It maps the information over the geometric Jacobian, uses the elliptic J invariant to ensure exact modular symmetry, and applies algebraic J stability, preventing the fields from collapsing. Pushing this stabilized, symmetric data forward yields an explicit parameter. The emergent physical coupling constant on the left is determined directly by the residue of the Galois L function on the right. A physicist measures this as a constant force of nature, like the gravitational or gauge coupling. Mathematically, that physical constant is simply the macroscopic shadow of a perfectly balanced arithmetic Galois representation. What happens to this information stream if we let the rank of the gauge group, the n in our equations, scale to infinity? This scaling factor, n squared, begins to act exactly like the inverse Planck constant. As n approaches infinity, the principle of stationary phase takes over. Destructive interference cancels out all the highly fluctuating quantum paths, localizing the data entirely onto the critical locus, where the effective action variation is zero. This mathematical cancellation forces the abstract algebraic data to condense directly into the differential geometry of the smooth Gillet-Soulé Arakelov metric. Physical spacetime is not a pre-existing container. Classical geometric paths, or geodesics, are forced into existence by this large N data collapse. With this metric vacuum established, we apply a discrete arithmetic shift, a Hecke operator, and evaluate how it interacts with the global Dirac data. Because this commutator does not vanish, the metric cannot remain invariant. Applying the Hecke operator acts as a discrete time translation, injecting a specific, localized quantum of geometric curvature into the system. Gravity itself is the direct physical manifestation of pumping discrete prime number data through the absolute adele ring. Up to now, we've relied on a perfectly smooth mathematical baseline, but if a prime number ramifies, the underlying curve loses its smoothness. The smooth prem torus degenerates into a singular varietal conoid. The data stream develops an internal singularity. When the math breaks at a ramified prime, it forces a corresponding break in the physical geometry. This mathematical breakdown maps directly to observable physical phenomena: topological defects, cosmic strings, and quantum gauge anomalies. A quantum anomaly is not a structural failure of physics. It is the exact semiclassical shadow of a prime factor dividing across the adele ring. First, we filter chaotic spectral data from the Dirac operator. Next, an intertwining operator maps it into automorphic forms for exact modular symmetry. Then, scaling the gauge group to infinity forces a stationary phase approximation, collapsing the algebra to generate an emergent metric. Particles, gravity, and spacetime are not fundamental building blocks. They are the explicit, inevitable outputs of the Adelic Langlands program processing prime numbers.